Hello students, this is Artitude. I am today discussing about analytic geometry, two-dimensional part on the topic straight lines. We will today discuss how equation of straight lines can be formed and what type, what kind of forms are made from those. So let's start. We take a Cartesian plan xy first. This is y-axis, this is x-axis, this is x-axis, and this is y-axis. Now, I want to say that actually a straight line can pass through from any quadrant. First quadrant, second quadrant, third quadrant, or fourth quadrant. From any quadrant. I am taking just a single straight line in such a way that I don't know the equation. I am taking the equation. Um, So, what kind of form we can give to conclude that to ensure the equation of the straight line? Now, I don't know anything, and that what points are satisfied by the straight line. The straight line AB, I'm giving the name. The straight line AB, I don't know what points are on the uh, straight line. I'm taking any point xy. Xy is a general point. It is showing that x can be any point and y can be any point on the straight line. Now I try to form a equation through using the general point xy. How? Uh, now you can guess that what is the basic thing about the straight line or another straight line. You take such a straight line in this way. Take another straight line. The basic difference you can find out straight lines C and D. Here also take xy is the general point, but the equation must be the unique one for one straight line. So what is the basic difference? You can see the tendency. You can look the tendency here and the tendency here is the different. Tendency means the straight line forms with the x-axis at the angle between the straight line and the x-axis. So this tendency is the difference for different straight line. And no different straight line have uh, same tendency if they are not parallel or the same straight line. Otherwise, must be different. So I will use this tendency. I am taking tendency actually is that tendency I am denoting it tendency. I am denoting it by m in general books. It is denoted by m, so I am using this m. So what will be the m? How can we measure the angle and to get a relation between x, y, and this angle, so that we can form an equation for any straight line. So now look, this is the point. Take this is the point xy. So draw a perpendicular on the x-axis. Now, since this point is xy, this point I am taking m capital M, and this point I am taking capital N, and this point I am taking O is the intersection of the two axes. So now M and I am taking the perpendicular on the x-axis from the point, and the coordinate of M is xy, the coordinate of the point N is x0. So the length of MN will be must be y. You can very easily know this is the uh, this is since the coordinate of M is xy, so ON must be x and Mn must be the y length. So now we know that about tan theta. If theta is the angle made by the straight line AB with the x-axis, then what will be tan theta? Tan theta, tan theta actually will be perpendicular by base. So y by x, y by x. Now one thing is clear that for every point this is constant for every point. The ratio of y by x for every point. So if one point is given, say 1 point x1 y1 is given. We don't know every point of the statement, but one point is given. This is x1 and y1. Now it is very easily you can calculate the tan theta value. Since you can calculate this, so we can very easily deduce the tendency, because tendency is the tangent of the angle. I have said earlier that the angle is the tendency. Actually the tangent of the angle is the tendency. So this is am is equal to tan theta y by x. We don't know every point, but if one point is given on the straight line, this must be equal to y by x1. So you very easily know the tendency. If you know the tendency, then we will very easily calculate the equation of the straight line. How? At any straight line must intersect uh, to the y-axis. We will use this straight line are each infinite in length. So it must if it must intersect y-axis. Otherwise, we will do two cases. One intersects y-axis, and one to other the case is that it does not intersect y-axis. When it intersects y-axis, here that you can view that you take this length, we don't know where it is intersect. I am taking this is 0c. 0 is the coordinate in x-axis, so it is 0 because at this point it is at the origin, or if this point lies on the y-axis, so its x coordinate must be 0, and c is the length from the x-axis. C is the length from the x-axis to the point. So 0c is the point. Now you can look that uh, here that what will be this point, this this is what will be this point, this distance. It must be the distance of if you take this is c, we know. So if we multiply c into tan theta, this is tendency is always always constant for to the full straight line. So if you multiply, then we will get this distance. So this distance I am taking that this is uh, I am giving it, this is x1 from 0 to this point. This point I am now giving name p. So OP has a distance x1. Now x1 will be c tan theta. Tan theta. Now to reduce the equation, we need to follow that Here is I have done a mistake there. Here actually tendency I am now creating. Tendency actually will be m is equal to tan theta equal to, since it does not form at the origin, if the angle forms at the point P, it must be y by x by x plus x1, the full length, x plus x1. So now we can very easily form the equation. Actually, we have created the equation form. So y is the general point. Y is the uh, coordinate of y-axis on any point on the straight line. So y will be m x plus m x1. I have done a mistake. Sorry for this. Calculation wrong. Sorry for this. Here I have done again a mistake. Actually, uh, C by OP, C by OP is equal to tan theta, right? C by OP is equal to tan theta, and OP is the x1. Right? OP is the x1. So C is equal to will be x1 tan theta, x1 tan theta. It is the first case when the straight line intersect the y-axis. So we have the equation form mx plus c. Now this is the general equation form of any equation. Y is equal to mx plus c. C is the cut point or intersect point of any straight line which intersecting the y-axis, and c is the distance from the straight line on y-axis from the origin. So this is the general form of any equation if it uh, intersects uh, y-axis. If it does not happen, take another example. If it is not happening, say any straight line is not intersecting the y-axis, then it must be parallel to y-axis. Means it must be perpendicular to x-axis. So this straight line is perpendicular on x-axis, means parallel to y-axis. In this case, the tangent uh, of this angle will be infinite, right? So here, since here this angle is pi by 2, so we have y is equal to uh, m m tan theta, m is equal to, here will be tan theta, tan pi by 2, which is infinite in length. So this form of equation cannot calculate it. So we use another form, which is y cannot be calculated. It cannot be calculated. It cannot be calculated in the general form. So you introduce another form. We cannot calculate it. Calculate it. So how can we uh, introduce such kind of straight line equation? Here, one point you can notice that the distance between the y-axis and this axis and this straight line is constant for everywhere, because both are perpendicular on the same axis. So the distance is always equal. So if you know that any point of the equation is x y, so what is the uh, xy is any point on the straight line, and if you know that the value where the straight line intersects on the x-axis, if you are given that at the point take c0. C0 is the point where the straight line intersects the x-axis. So this distance must be c everywhere. So one condition is constantly or invariantly followed by the straight line. This is that x must be equal to c, and y cannot be calculated. So we will use this form to declare the equation, because y cannot be calculated. So x equal to c is the equation of the straight line. If any straight line is parallel to y axis on perpendicular on x axis, then this form will be used to express an equation of the straight line. Now if we will take another form, straight line can intersect y-axis as well as x-axis. If such kind of case happens, then what will we do? Take this kind of straight line. Here one straight line. It intersects y-axis as well as x-axis. This is x-axis. This is y-axis, and this is AB straight line. Here, this is the origin O, and it is we are taking P intersect at the straight line and y-axis, between straight line and y-axis, and this point is Q, the intersect point between the straight line and the x-axis. Now we wish to formulate the equation of this equation. So how we will use the general formula? We know that y is equal to mx plus c. mx plus c. M we can evaluate by using given by any point. So here given point is we know that c. What is the c? Here the point 0, the coordinate of the point P is 0c. So the length is c. Now we use this point to evaluate m. So how can we evaluate m? So m will be here you can look this. This will be take there is a very ordinary general point xy. This is xy. So if this is xy, then this will be y, and this will be x. This will be y, and this will be x. Now we know that this length is c, and this angle can be calculated. This is pi minus theta. So we know tan theta, the tendency. So what will be tan pi minus theta? Tan pi minus theta, pi minus theta. On the second quadrant, this is tan theta is negative, so this will be minus n. Now one thing is that this angle can be calculated. Now if you take a perpendicular here, then this angle is minus m, and this is x, and this will be y minus c, right? This is c minus y. This is c minus y, and this is c minus y, and this is x. So here we are getting that c minus y by x is equal to minus a, minus a. We are getting the same form, but we wish to we are just checking this, that this general equation satisfies this condition or not. But this is okay, this equation can be used if we know the value of the intersect point 0c, but we want to use this intersection point. This is 0c, and take this is a 0. We wish to use these two points to evaluate the equation. How this can be also used, but we want to use these 2 points. How we can use? Now check. This is wasted time. I am taking a0 this point 0 b, now this is b square. By Pythagorean theorem, it is a right angle. So now this here and here is the step, right? Now I'm taking any point this this is xy. Now this is the general point. Y, A and B are parameters can be changed, but we are not changing because these are constants for this straight line. A and B cannot be changed; these are constants. But xy can be changed for this straight line. For this straight line, xy are changing points, can be any point. A0 and 0b are the constant points. So we will use this way using xy. So using xy we can use that But this distance is from the straight line and from the origin. This is root over x square plus y square. Now if you will take the distance is p, then p will be root over x square plus y square. Now p is taken and take the angle made by p is theta. This is theta angle made by p. So with the x-axis. So now we can view that y is equal to what will be the x? X will be y is equal to p sin theta and x is equal to p cos theta. So we know that sin square theta is equal to cos square theta is equal to 1. Sin square theta plus cos square theta equal to 1. So from this using this we will get that uh, now what will be x by a? give A0, this is 0b. Now if we remember for a right triangle, sorry, there is a geometrical property for a right triangle. Two are perpendicular, both are perpendicular. The ratio of two angles, two sides are equal to the ratio of the these two perpendiculars and two. We will take A, B, C, P, Q, then AP by PB, PB by BC equal to AB by QC. We will use this in this here. This is Y, this is B, and this is A. We can also uh, uh, we will take this theorem for these two perpendiculars and on the x-axis. So here, sorry, here I have given again wrong. Actually, this property is in this way. Take the right angle. So here, if we take another right angle, since the both are perpendicular on the same line, both are 90 degrees, means ABC angle, ABC angle and PQ angle have similar angles. How? Angle APQ is equal to angle ABC, angle AQP, angle ACB is equal to, these are also equal because two are perpendicular, but one is the intersector and A is the same angle. So uh, for triangle APQ and for triangle ABC, three angles are similar. So AP by AB, AP by AB is equal to PQ by BC, because AP is the opposite side of the angle Q and AB is the opposite side of the angle C. That's why AP by AB is equal to opposite side of this angle A for this triangle APQ is PQ, and for this triangle for the angle ABC opposite side is BC. So will be PQ by BC. And last we have also one similarity, one similar ratio is AQ by AC. We will not use this here for the hypotenuse on the hypotenuse. Is the UU AP by AB is equal to PQ by BC. So here will be it will be that A minus AX by A is equal to y by b, y by b. So uh, we have the relation here, 1 minus x by a is equal to y by b. So at last we conclude that x by a plus y by b is equal to 1. Two important relations I have obtained. We'll discuss further the straight line and to obtain other equation forms. Here I have obtained general form of the equation and another form of any straight line intersecting both y-axis and x-axis. These are two important forms, and the other forms I will discuss in another video. Thank you and subscribe this channel and share with your friends. Thank you.